What's up guys, Matt and Nickey here. Alright, so that Krypton Green ZL1 that I've been talking about doing the 2650 on forever, I got it on the dyno, so let's go check it out. So, kind of review 2017 ZL1, awesome Krypton Green color. It might look kind of funny, I'll just go over that quick. Those are just for the dyno. So he came in on a drag radial, and we do not like, if we can avoid it, we don't like putting drag radials on those rollers. The knurling on the dyno roller is pretty rough, and it really chews. You do, if I start doing tuning pulls where I'm doing 5, 6, 7 pulls on the dyno, it really chews up the drag radial. So that's why those are on there. Those are just some 2010 Camaro wheels we have laying around that we use, that I throw on cars for, in case a car comes in with a drag radial or a slick or something like that. 5th or 6th gen, I can throw those on. Surprisingly, a 5th gen wheel does fit on the back of a ZL1, as you can see. It fits, it clears the brake. But yeah, that's something I do for the dyno, just again, so we don't chew up somebody's drag radials. These things are expensive, like $350 a piece, and you can seriously wear, especially if you get into like doing like 10 pulls, over a course of like an hour or two, you can really wear a set of drag radials out on those rollers. So we avoid that. So it might look a little funny, but again, it's got this is our serialized car. So this is ZL1, 6th gen ZL1 number 3. So it's got our stripe on it. See that stripe we had made for us, and kind of stands out against that green. It's pretty cool. But yeah, so last time you saw it, that last video we did where we kind of reestablished a baseline after the customer brought it in, it had the stock blower on it. So now, again, just like that last video I made, another 2650. Basically all we did was install the blower. We retained we swapped his 103mm throttle body he had on the snout I ported on the stock blower. We did switch over to a Rotofab Big Gulp that's a 5-inch cold air instead of the 4-inch that we had on it. When we originally did this car, Rotofab wasn't offering the 5-inch cold air, so we had a 4-inch on it. They've since come out with this Big Gulp series. This is really nice. These things we pretty much only use Rotofab cold airs because they just, out of all the cold air intakes I've tested, I know there'll be battles over cold air intakes of who makes the most. We've just on our dyno, what we've tested, the Rotofabs make the most power, so that's what we use. The other cold airs out there there are other really well-made cold airs. We've tried them all, and these are the ones that we like. So then we added a catch can on it. Basically, on these LT4s, we use Tracy Lewis catch cans. He actually has a really trick plug. So on the valley plate, normally these valley plates vent right into the bottom of the snout of the supercharger. So we avoid that because you're just going to get excess oil, especially you start cranking the boost up. There's you start pushing crankcase pressure up just a little bit. You start putting more oil into the blower. Oil causes detonation. We don't want to be burning oil through an engine like this. Even just a small amount in the intake can cause detonation. The oil creates hot spots in the combustion chamber, and yeah, basically it causes knock and it causes detonation and makes the car slower. So catch cans are kind of a must we pretty much put catch cans on everything we do. So that intercepts, basically you pull the plug out of the stock valley plate, and Tracy Lewis has an insert that goes in with a barbed fitting on the end, then we can intercept that, instead of it going right up into the blower, we can intercept it. And on this Magnuson, it just goes right into the snout here after the throttle body. So pulleys, we originally had the stock upper when we had the stock supercharger on, we had the stock upper, and we had a 9.15 lower balancer ring on an ATI balancer. So we retained the balancer. Because the 2650 is just, it's a bigger blower, it moves so much more air than the stock LT4 blower, we have to change the pulley combination around. So 90mm upper, and instead of the 915 lower, we went to an 8.4 lower, which is down kind of close to stock. I think a stock is around 8 inches or so. And that's given me, and after I do a dyno pull later, I'll probably go over the data log and we'll look at the boost, but I'm seeing about 16 pounds of boost. That's about where I'm at. It's just touching 16, and for 93 octane, that's pretty much where we leave off. Also for the fuel system, I'm right up against the limit, so at the power level I'm at in this car, and I'll do a dyno video, and then we'll look at the final pull, but I'm about mid 700s, I'm 740s, 750s. I'm at the limit of both fuel systems right now. The high side and the low side pump, I'm at 65, 6600, right where I'm shutting it down, I'm pretty much hitting the wall, and that's really what we find on the LT4. So again, this is a stock cam. There's no water meth on this car, which we might add later. But everything else is stock injectors, stock high side pump, stock low side pump, no booster pump, no auxiliary fuel pump, nothing like that. So we're just pretty much taking this blower right up to the limit of what the stock LT4 fuel system can give us. So, and that's pretty much it. I mean, we didn't change a whole lot around. You know, obviously there's a little bit of plumbing change with the intercooler. The first one of these we ever did was we just had the blower and we had to make all this stuff. Now Magnuson, it comes as a kit and it's a little bit easier for us. You know, all the intercooler plumbing. They give us this little tank. We've used a tank from Big 3 Racing. That was a really nice unit on some of the other ones we've done. It's a real tight fit with this blower and the way the coils have to sit. You got to move some stuff around, but it is a super nice piece. But just for ease, we went with Magnuson's kit little reservoir here. Their hoses, their hose system is pretty nice. It actually fits really nice. One of the other reasons we really like Magnuson's is their kits are really well made, and all the brackets and stuff are well made, and everything fits pretty good. So still have the factory heat exchanger up front. We didn't change that. Again, yeah, I mean, it's still, so it's those American Racing 2-inch headers. It's our Nickey Edition 2-inch headers, and to a 3-inch X pipe to the stock muffler. So basically this system's like a 3/4 system. It's the headers, it's the 2-inch headers to a 3-inch primary, 3-inch X pipe, and then there's extension pipes, and we cut the stock system off the muffler, and the 3-inch pipes, the way American Racing makes it is they clamp right onto so basically we leave a few inches at the muffler at the pipe, and they clamp right onto that few inches of leave, and works really nice. So if you want to retain the stock muffler, obviously there's other options for mufflers, and but for ease on this build, we just went with the stock muffler, and customers likes the way it sounds, so we left it alone. Yeah, but otherwise, that's kind of it in a nutshell. That's the 2650 install, and yeah, so I've done a couple pulls already, and I'm real close on it as far as, you know, getting the timing and the fueling right with this blower, with the added boost on top of the stock blower. But yeah, what I'll do here is obviously I'm going to put the camera down. I'll put it on the tripod there, and I'm going to do a couple more pulls on it, and we'll take a look at one of those pulls when I'm done, and we'll see where we end up. All right, guys, let's go take a look at this. Take a look at this graph here. So, 748 for power, for horsepower, and 737 for torque, pound-feet torque. So, yeah, that's I'm happy with that for just 93 pump gas. That's almost 100 horsepower gain over the stock supercharger. I think we were in the 660 range for 660 some for the stock blower. I think our best pull ever on this car was maybe close to 670 on a cold run and 660 on a warm run, something like that. So this is a hot run. I just did 3 pulls in a row on it, back to back to back, just because this car gets raced in the heat in the middle of the summer, and that that Chevy streetcar shootout, basically that's what they got to do. They got to do a pull or a quarter-mile run, pull it up to the side of the track, and you get a little bit of cool down. But you know, when it's 90 degrees outside, there's really not much cooling down. Yeah, they can't open the hoods, they can't do anything. They can basically just sit by the car, wait for their next run. They do 3 runs like that back to back to back. So I like doing that on the dyno. Just run them a few minutes apart just to make sure. So this is my 3rd and final run. So we can kind of take a look at a data log here. I was just kind of bringing that up here to kind of go over what we got going on here. So I know there's a lot to look at here, but these Gen 5 engines, we do a lot, data log a lot of channels on the Gen 5 engine. So here's pretty much our run. You can see here, so up at the top here, RPM, so we're 2,000 RPM, that's about the start of the pull. You can see my accelerator pedal position I log. That went up right here to the peak, right there. So that's about the start of the run, 2,000 RPM. And so we're starting at about 143 kPa for boost. I read boost in kPa, so that's absolute. So we gotta take away 98 kPa, that's atmosphere, or just as we're sitting here, you know, there's 98 kilopascals of atmosphere pushing down on top of us at all times. So that's how these sensors read, as an absolute. So we're about 45 kPa, which is, gosh, off the top of my head, 6 pounds of boost, something like that. That's the start. So again, I was talking about how those Magnusons ramp boost in, and I'll get a exact, actually. I got my calculator set up here to do this, so oops. Yeah, 45 kPa is 6.5 pounds of boost, so 6.5 pounds of boost. That's where we're starting. So and then we are ending. See, we're getting up there, 60, just about 6,600 RPM, 211 kPa. Again, take 98 away, so we're 100. We go to 113 kPa, and that's going to be 16.3 pounds of boost. That's about, again, that's what I was talking about before. We're hitting, 15.5 to maybe just a smidge over 16. You call that about 16 pounds of boost we're hitting. And that's at the very top. So you can see this white line here, and this is the boost level. And you can see, again, we're starting out at that, 6.5, and it just climbs as the run continues up. You can boost kind of moves around that little wiggle in the boost line. That's as the cam retards. The boost will kind of move around a little bit. The cam retard is not an exact thing on these cars. It does not follow the commanded to the T. It moves around a half a degree, and that kind of makes the boost curve just a smidge move around a little bit. But you can see it's generally a gradual curve up. So by the top, we're seeing that 16. So these really ramp boost in similar to like a even a centrifugal with the way we have this one pulleyed. Now, as you pulley them harder and harder, they will make more boost down low in relation to how much they're climbing. So here we're seeing a 10-pound climb, and that is low RPM. I mean, it's 2,000 RPM. I shouldn't say like a centrifugal, because this car is 16 pounds of boost with a centrifugal blower. If we were hitting 16 peak, we'd be down to like 3 pounds of boost at 2,000 RPM. So it's still making more boost down low than what like a centrifugal, like a ProCharger D1SC would make, especially like a D1X. A D1X would really ramp boost in. The D1Xs and the P1Xs are really RPM blowers. They like RPM and they like to be spun. So I'm getting a little off track here, but just to kind of give you guys an idea of what I've seen with the different stuff that we've dynoed. So timing, I'm pretty much 17, climbing to just into the 18s. So my spark line here, you can see it is showing knock, but the trick with knock is on HP tuners is the Gen 5 platform uses a table called static knock retard, or static spark retard. And from the factory, they dial in, the LT4s have, 1 or 2 of the cylinders has 3 and even up to 5 degrees of timing retard per cylinder. So individual cylinders can have ignition trims. So I actually still use that. So I actually pull some timing. There's usually cylinder 5 and 7 will when you're reading. So again, I'm going into the knock sensors here. I'm data logging every single cylinder. Now there's only 2 knock sensors. The ECU uses the frequencies that those knock sensors are generating to kind of guesstimate which cylinders the knock is coming from. It's actually pretty accurate, because when I'm tuning these things, usually 5 and 7 will show knock first. And if I go to that static timing retard table, which is what you're seeing here on the knock, when you put knock retard, timing retard in those static tables, it shows up in the data logger as knock retard. And so that's why we're seeing knock here. And you can see I have a degree dialed in, then I have 2 degrees dialed in here, and then it drops back down to 1. So it's, you can see, if I was seeing knock, you'd see spikes in this line. You'd see like a big spike, or, you know, it wouldn't be smooth like this. And this is because I'm commanding this retard, and it's just showing up as knock retard. So yeah, going back to the spark line, you got a little dip there. I could probably clean that up, but some of this tuning, since this guy drag races, a lot of this tuning we like to do at the track too. I like to finish this off. I let this guy, we get to the track with him, and he's always into going to the drag strip with us just for test and tune. And I like, you know, I'll do some data logging, especially at the track for sure. You know, I'll throw the laptop in the car, he'll go do a run, he'll come back, I can take a look at this stuff at the track too. So yeah, that's our boost. That's where I'm hitting spark. My cam timing tables are pretty much stock. There isn't a whole lot to do there. Now, air fuel ratio, you can see, so this is my wideband down here. These Gen 5 direct injected motors, you can definitely run leader. So in an LS here, I read lambda. LS motors, I'm usually 0.8, 0.81 lambda on a boosted car, on like let's say an LSA car, a ZL1 or a ZR1, or even if you're boosting like a Camaro SS, like an LS3 or anything LS, you know, if you're doing like a turbo truck motor or something like that, that stuff. I'm usually trying to target on gasoline 0.8, 0.81. E85, you can go a smidge leaner on the LS motors. But back to the Gen 5 motors, you can notice how lean this is. This is almost getting into normally aspirated air fuel ratio territory for like an LS motor. It might be a smidge rich there, but you can see I'm starting out at 0.85. Boost is a little lower, cylinder pressures are lower. I can be a smidge leaner, and then you can see how that climbs just into, it starts to get 0.84, maybe just at the top there I richen up because we are seeing quite a bit of boost. But if you go too rich on these motors, you'll actually create knock. And some of that is too is the ignition pulse width, the injector pulse width. As the injector pulse gets wider and wider, the end of injection gets closer and closer to when the spark plug is actually going to fire. So you're spraying fuel as the piston is coming up into the compression stroke, and you really got to limit how much you're doing that, because then you're just starting to push. You actually will start to push fuel back into the injector. The injector's trying to open and push fuel out. Granted, I do have the fuel pressure turned up in this thing to about 3,000, 3,100 psi, but you're still trying to come up on a compression stroke, which there's a lot of cylinder pressure in a compression stroke, and it can be almost half of that. So you're truly trying to limit how far your pulse widths are. And so here that's at the very, very top of the run. 5.7 is pretty high. I usually like to try to keep them down here near 5. You can see that it's only climbing up into that 5.5 range at the very top, and that's where we're gonna have this car shift to the 6,500. So it's just touching it. I could maybe even just trim this off just a smidge leaner up here, but it's pretty close. So that's just kind of my process on the DI motors. I'm sure if there's any other tuners watching this, maybe somebody will critique it and say, that's not the way I do it, but this is the way I do it. I've tuned lots of these things. I have a 2017 Camaro SS. It's normally aspirator now, but I run it on E85, and I'm going to boost it eventually in the future. And I've got tons and tons and tons of dyno time with that car and playing with these DI stuff. So yeah, that's kind of a little overview of the data logger. The other cool thing that we can go across, I don't have it graphed, but I have it on my PID list here, is the manifold temperature. So you can see here, this, again, we're gonna go back to how awesome these 2650s are at cooling. So that's the start of the run. You can see it's 2000 RPM, and we're at 91 degrees Fahrenheit for manifold. So manifold air temp, that's the earlier LT4s use manifold air temp. I still log IAT2 because what I've found in the 19 and 20 ZL1s and Z06s is that they went back to intake air temp 2, like an LSA or a ZR1. LSA, LS9 stuff used IAT2 for the supercharger air temps. The LT4 early on went to what's called manifold air temp, and then they went back to IAT2, just GM engineers doing their thing. So what we're reading here, so I log everything. I have so much stuff logged, but so we're reading here, this is what we're reading. There's a sensor screwed into the front of the blower case, and there's a breakout for the stock. The stock map sensor on the LT4s has the intake air temp sensor in it. So there's a breakout on the Magnuson kit that breaks that out to oh, my interior lights just shut off, but breaks that out to a regular IAT sensor that screws into the front of the lower tub on the passenger side of the supercharger. So you're reading it basically as it's coming right out of that intercooler brick. So we're starting to run at 91 Fahrenheit. Now watch this. On the stock blower, if we were starting there, the top of a pole like that, we'd see 140, 130, 140. The Magnuson 2650s, that's 2,000 RPM. Watch this temperature as I'm scrolling this across. 90, 88, here it's dropping. 88, 86. And I think at 88, back up to 88, 90. You can see that out of all, I've tuned hundreds and hundreds of LSA, Eaton cars, Whipple cars, Kenny Bell cars, hundreds of them. I mean, over the years, I've been doing this for 15 years. Not one PD blower have I ever seen, besides this 2650, drop IAT2s, into manifold, the actual air coming out of the intercooler brick. So it's going out of the supercharger rotors through those intercooler bricks, and right before it's going into the cylinder head, that's what we're reading, where we're reading the air temperature. I mean, that's just awesome to have air temperatures that will drop. And we've seen this similar at the track when we were at the fall on the track with a couple cars we've done 2650s on. Same thing, I'd do a burnout, IATs would be 100, 105, and by the top of the quarter mile, they were still 105. So pretty awesome. I mean, this blower is just awesome. I know I rave a lot about it on this channel, but I can't wait to put one on my car and see what it can do. So yeah, there's a data log of that 748 horsepower run that you just saw, and kind of get an idea on the data logging and kind of the numbers that you're going to see out of one of these things. Boost wise, with this pulley combination, we can go back out and kind of go over that. I know I went over that earlier in the video, but again, this is basically our stage 1 package on this car. I mean, it's all external stuff. So it's got that big intake, it's got that pulley combination I was talking about before, and obviously the blower, our American Racing headers, and with the 3/4 system to a stock muffler on this car. So, and yeah, this car will go to the drag strip in the spring, and what we're probably gonna end up doing in this thing is we're probably gonna put a water meth kit on it, and because I think what he wants to do is he wants to run the 10.0 index class. So in that Chevy Street Car Shootout. So to get him, he was mid-10s. We just gained him about 90 wheel, and it's gonna be real close. In the heat, use 10.6, 10.7. Probably gonna put a water meth kit on it just to make sure he can hit that 10.0, because basically the car needs to run. This car does need to run. It needs to run 9.9s in cool air, and maybe even 9.80s in cool air to really do what he needs to do, where he can be consistent 10.0s, 10.07, 10. But to win that class, where he wants to win it, you got to be a 10.0. You got to be competitive. You got to be right at that 10.0 mark. So I think a water meth kit will be in order on it. I want to just kind of establish just boost only 93 octane first before we went to that water meth kit. And in a future video, when we put the water meth kit on it, I'll do another video on the dyno with it and see how much power we can pick up on it. So, but yeah, that's pretty much it for now on this car. I got a Jeep SRT I got to put up on the dyno here next, and probably make a video on that when I'm getting close on that. But yeah, thanks for watching, guys, and we'll talk to you later.